Hello everyone. Today I'm recording for the asynchronous class since for chapter 1, which is basic concept and principle for this static of rigid bodies subject. So it's only the chapter 1 is only around 20 slides. I will be recording this one as a asynchronous class activity, so you can check watch this video so that you will be able to solve the quizzes that which will be followed after this PowerPoint presentation, together with the questions coming from the another chapters. Probably from chapter 1 and 2 will be the one quiz, which will consist of computation as well as multiple choice question. So let's start with the mechanics, with the certain definitions. So what do you mean by mechanics? Insert: mechanics is a branch of physics or physical science that is concerned with the state of rest or motion of the bodies subjected to the action of the forces. There are three different types of mechanics: rigid body mechanics, deformable body mechanics, fluid mechanics. And within the rigid body mechanics, it is further divided into static and dynamic. So this subject is all about the rigid bodies, especially the static rigid bodies. So static means the condition where there is an equilibrium of the bodies, or the forces are equal from all directions. So insert: by definition, the static deals with the equilibrium of the bodies, that is, those that are either at the rest or move with the constant velocity. So you can see the picture. In the picture you can see the aircraft, which has 4 different forces. So 4 different forces you can see: lift, weight, thrust, and drag. So if it is the static conditions or equilibrium conditions, the thrust shall be equal to the drag, while lift should be equals to weight. And the condition is, if they are equal, the condition is said to be in equilibrium conditions or the static. Then when we talk about the dynamics, it is concerned with the accelerated motion of the bodies in terms of flight path, in terms of relative wind. There's a possibility that the forces will change. Thrust shall not be equal to the drag, while lift will not be equal to weight. That is dynamic. There's a changing, the forces or the motion of the bodies are changing. It's not in the equilibrium conditions. But when we say if the airplane is in the static condition or equilibrium conditions, aircraft should be flying at the constant speed at the constant altitude. But if the aircraft is descending or climbing, that forces that the mechanics that we will be talking during that time is the dynamic, because if the aircraft is descending, the weight will be higher than the lift. If the aircraft is accelerating, thrust should be higher than the drag. So when we talk about the mechanics, there are basic quantities you must be able to know, like length, time, mass, forces, etc. So length is used to locate the position of the point in space and thereby describe the size of the physical system. Time is conceived as a succession of the event. Mass is a measure of quantity of matter that is used to compare the action of the body with that of another, while forces is considered as a push or pull exerted by one body on another bodies. And there are different units for all of these quantities. So while you are performing the problem solving questions, you need to check if the units are same with another. Let's suppose if you are talking about the length, there's different units, feet, meter, centimeter, millimeter. So while performing the problem solving, you need to check and confirm that the units that you are using for the problem solving must be same. All the units must be same for the length, for the time. If you are using the seconds, it should be same with the second also in another units. So idealizations, the particle has a mass, but the size can be neglected. Like when we say the cotton also have a mass, but it's not necessary that if the object or the particle have a certain mass, it is not necessary that size will also be same. So depending on the density of that particle, the sizes can be different. That's why the size can be neglected, but particle will have mass. The rigid body can be considered as a combination of a large number of particles in which all the particles remain at the fixed distance from one another, both before and after applying the load. Concentrated force represents the effect of loading, which is assumed to act or point on a body. So while talking about this mechanics or the static of rigid bodies, we also need to be aware of these Newton's law of motions, because static, we are talking about the movement. So that time these three laws of the Newton's are essential to understand as well. So the first law of Newton, or Newton's first law of motions, which is also known as law of inertia, it states that particle originally at the rest or moving in a straight line with a constant velocity tends to remain in this state provided the particle is not subjected to an unbalanced force or external force, which means as long as there is no external force, if the object is moving, it will continue moving, or if the object is at the rest, it will remain at the rest until there is external force. So that means all the forces acting on the body should be in the equilibrium. Doesn't matter how many forces is acting on the body. For example, here in the diagram you can see F1, F2 and F3. So all the forces acting on the body should be equal, so that if the object is at the rest, it will remain at the rest. If the object is moving, it will keep on moving at the same velocity. Then second law of motions, which is also known as law of acceleration. So as per the second law of Newton's second law of motion, it states that particle acted upon by an unbalanced force experiences an accelerations that has the same direction as the force and magnitude that is directly proportional to the force. In short, F is equals to mass times acceleration. So force should be equals to, or force should be the product of mass and accelerations. The third law of motions, law of action and reactions. So as per Newton's third law of motion, in basic understanding we can say each and every action have equal and opposite reactions. So the mutual forces of action and reactions between two particles are equal, opposite and collinear. And that is also the principles for the development of the rockets, development of aircraft propelling forward. That all comes with this Newton's third law of motions. So while talking about the motions, we also need to know about the measurements. Measurements have different units depending on the system. Basically, there are several systems used internationally, but among several systems of units, two major systems are more common. One is SI unit, which is a standard international system of units, and another is the US customary unit. For the length, as per SI unit, they use the meter. Time, they use second. For mass, kilogram. And for forces, Newton. So this Newton is the derived unit with the combination of several units. Like when we say Newton, it is denoted by the alphabet N, which is the product of kilogram meter per second square. Then, according to the US customary units, the unit for the length is the foot. For the time, it's second, and for the mass, slug, which is also a derived unit, the pounds second square per feet. And for the force, the unit they use is the pound force. Then in terms of conversions, so it is also essential, as I mentioned, if you are doing the problem solvings, you need to ensure that all the units that you are using is same. If there are several units related to the length, you need to make sure that it is same. If you are doing the problem solving using the SI units, for the length you need to convert it into meter. If it is given it in the kilometer, make sure that you convert back to meter. If it is centimeter, again convert to the meter. For the time, if it is given in the hours or the minutes, make sure that convert to second. For the mass, if it is the kilogram, pounds, gram, etc., make sure that you convert it to the kilogram to get the accurate answer. Otherwise, your problem solving will not be accurate, or you will not get the correct answer. So similarly for the US customary system also, convert the length to the foot, time to second, mass to slug, and force to the pounds. So conversion factors, you can use the calculators, or you can use the internet to search all the units which are not available here in the PowerPoint presentation. But for the force, it's pounds as per FPS, feet per second. It is equals to the 4.448 Newton. If you are going to convert, you can use these units. Mass, one slug is equals to 14.59 kilogram. Length, 1 feet is equals to 0.3048 meter. Then if the units are given in the exponential form, the prefix, the word you call prefix that you will be using are several here: giga, mega, kilo, milli, micro, nano. And the SI symbol that you will be using is the capital G for giga, capital M for mega, small k for kilo, small m for milli. So make sure that don't be confused with the capital M and small m. Capital M is for mega, while small m is for milli. Milli is 10 to power minus 3, or you can say 1 divided by 1000. Then for mega, 10 to power 6. Then for micro, you will use the Greek symbol. Then for nano, you will use the small letter n. And the units are, for nano, it is 10 to power minus 9. Micro, 10 to power minus 6. Or in short, you can just, if there's a minus, just divide 1 divided by 10 to power 6 for the micro, 1 divided by 10 to power 9 for the nano. And the kilogram is the only base unit that is defined with the prefix kilo, 10 to power 3, or if it is in the 1000 units, so we can just convert it into 1 kilogram. So we have some examples. Here is the examples. Then you can use these examples to solve the questions that you are getting in the activities after I complete the chapter 2. So here you can see 2 km per hour. You need to convert it into meter per second, and you have two questions actually. So 2 km per hour, you need to convert 1 into meter per second, and you also need to convert into feet per second. So to convert that, it's simple. 1 kilometer is 1000 meter, and 1 hour is 60 minutes times 60 seconds, so which is 3600 seconds. So as per questions, 2 km per hour, 2 km per hour, you are going to convert into meter per second. So what you are going to do is 2 km, 1 kilometer is 1000, write it down. So you can cancel the kilometer, the remaining will be meter, and for 1 hour it is 3600 seconds. So this hour and this hour will be cancelled, so the remaining will be meter per second. So just compute 1000 divided by 3600, which will be 0.556 meter per second. And the same questions, it's asking to convert you to feet per second also. For feet per second, 1 feet is equals to, as per conversion rate given here, 1 feet is equals to 0.3048 meter. So for that, you can just multiply 1 feet, because you already converted in a meter per second. If you want, you can convert directly from kilometer per hour to feet per second, but the conversion ratio that it's given here in the PowerPoint presentation is 1 feet to meter, 1 feet to meter. So what you can do is e.g. 1 feet is equals to 0.3048 meter, so 1 theta, then this one 0.56 meter divided by second, then 1 feet is equals to this one. So just do the problem solving from here. Multiply, divide 0.556 meter divide by 0.3048 meter. So meter will be cancelled. The remaining units will be feet and second. So you will get the answer of 1.82 feet per second. So you just need to practice actually. I can give you several examples or several problem solving, so you can master the problem solvings, so it will be easy for you to do the problem solving. You don't need to be afraid of these kind of problem solving questions. So we have another example. Convert the quantity 300 pounds second and 52 slugs feet per cubic feet to appropriate SI unit. So SI unit is pounds second. So how can we convert SI unit? It is a force second, that is the torque ba in there. Then the slug cubic feet. Here you can see slug cubic feet. So how can we convert back to the SI unit? Here, 1 pound is equals to 4.448 Newton. So pounds convert to Newton, because in SI unit the force is Newton. So Newton, 1 pound is equals to 4.448. So pounds will be cancelled. The remaining will be Newton second. So 300 pounds second is equals to 1334.5 Newton second. And another question given here is the 52 slug per cubic feet. You need to convert it into SI units. So slug is the mass. So in SI unit, the mass is kilogram. So 1 slug is equals to 14.59 kilogram, and 1 feet is equals to 0.3048 meter. So the question is 52 slug per cubic feet. So 52 slug, 1 slug is equals to 14.59. So slug will be cancelled. The remaining will be kilogram. Then the feet, SI unit of the length is meter. So we need to convert this feet to meter. So for that also, 1 feet is equals to 0.3048 meter. This feet and this feet will be cancel. So before cancellation, you need to make sure that there's a cubic, diba? So whole is whole cube. So 1 cubic feet, it will be cancelled with this one. So the only thing is 0.3048 cube. So just do the problem solving here. So you will get the answer of 26,800 kilogram per cubic meter. Simple pa din. Then we have a third example. Evaluate each of the following and express the SI units having an appropriate prefix. So here 50, we have 3 questions. The first one is 50 millinewton times 6 giganewton, because the capital G is giga, small m is milli. You can check here, small m is milli, capital G is giga. So giga is 10 to power 9, milli is 10 to power minus 3. So simple. You need to, as per questions, you need to make it into appropriate prefix. So milli, you can bring it to, milli is 10 to power minus 3 multiply giga is 10 to power 9. So you will get the answer of 300 10 to power 6 Newton square, because it will Newton square. Then plus 9, you can just add or subtract the exponential. If it is divide, subtract. If it is addition, add. So minus 3 plus 9, that should be equals to plus 6. You can multiply this one, or you can just leave it like that way, because you already remove those prefix giga and milli here. Then you need to bring it to the SI units, kilonewtons. Here 300 times 10 to power 6 Newton square. So 1 kilonewton is equals to 10 to power 3 Newton. Here square. So it will be 300 kilonewton square, because this one will be cancelled. This 10 to power 3 plus 10 to power 3 times 10 to power 3. So exponential 3 plus 3 will be 6. So this 6 will be divided by this one, so it will be kilonewton. Then second, 400 millimeter times 0.6 meganewton whole square. So millimeter 10 to power minus 3 multiply mega 10 to power 6. So you'll get the same answers in the same way. So it will be 144 giga meter Newton square. Then we have a third example, 45 meganewton cube divided by 900 gigagram. So gram you need to convert into kilogram, Newton you need to convert it into another SI unit. So mega 10 to power 6, giga 10 to power first you convert it to kilogram, then giga 10 to power 9. So it will be, the remaining will be 10 to power 900 times 10 to power 6. So in the same way, it's hard to explain here without the whiteboard. Any questions you can ask, you can email me, or you can comment in the announcement that I will be posting in the canvas, or you can ask the questions directly to our group chat if you have any questions. And for next meeting, we will be having synchronous class for chapter 2. Okay, that will be all for this chapter 1. See you for next meeting, and have a nice day.